All right, so I think it's 14 questions we need to get through today. The reference sheets you will have tomorrow, I have on another slide here. So, there's two reference sheets. This is what you will have for this first couple questions. But remember, it says this because everybody ignores this. Okay, it says it right on the reference sheet. These formulas only work if theta is in radians. All right. So question 1 says, determine the approximate length of an arc. Do you remember the formula for arc length, anybody? Good call. Sorry, I'm struggling here. It's this one. It says arc length equals radius times angle in radians. So if it has an 11 centimeter radius, that would be your R. And then you have to multiply by theta. Now, to change degrees to radians, I just think of it as a dimensional analysis question. I need to get rid of degrees, and 180 degrees is equal to pi radians. Does that seem okay to everybody? So you could reduce that, but we're just going to type it in our calculator anyway because it says round to the nearest tenth. So 11 times 80 times pi divided by 180. It wants an estimate, not an exact answer. 15.4. And the label on that, it's a length. So what unit of length did we have going on in this question? Yep. Find the angular velocity of a gear that is turning, okay? Anybody remember the big deal about this? What does RPM stand for? Rotations or revolutions. I'm never sure which one it's officially, and it may be both. But it's not radians. So what do we have to do? One rotation is really 2 pi radians. So now we are rid of rotations. We're trying to find a linear velocity. If you go to the formulas, linear velocity is the V. So we have arc length divided by time, or over here we have angular velocity times radius. Well, so far we now have radians per minute, which is an angular velocity, right? So it's 8,000 pi. And we know up here the radius is 5. So if we just multiply by 5 centimeters, we'd have angular velocity times radius will give us linear. This part was the angular. And our label would be centimeters per minute because remember, doesn't say we have to do any conversions other than centimeters per minute is fine. So we just need to type 4,000 times 2 pi times 5. If we had to change to seconds or something, it would be another story, or to hours, but it does not specify, so we can just put that ginormous number on there. 125, 663.7. Not if it says to the nearest tenth, which it probably does. Okay. Any questions so far? Remember, these are just like the finals, so please ask if you're not sure what's going on. This is a lovely hint. It says sketch. So if we graph -5, +12, connect back to the origin in our bow tie triangle, and it says find the cosecant. Do we need the hypotenuse for that one? So either ignore the negative and type it in your calculator or use parentheses, but we get 169, so we get 13 here. And then cosecant, be very careful. I think they're even on the reference sheet, aren't they, somewhere? Is it on the back of your trig reference sheet? I feel like it says cosecant is 1 over sine. Okay, so it's the flip of sine if you get confused. So, but you do have to know your sine equals opposite over hypotenuse, or else sine equals y over r, so that you can flip it over. So this would be cosecant equals hypotenuse over opposite, which would be 13 over what? Yes. Watch your signs carefully, okay? We're in quadrant 2, so the sine is positive, so is cosecant. Okay, number 4 says find the exact value of the cotangent of 5 pi over 3. So you go to your unit circle reference sheet and you go here, 5 pi over 3. What was it again, guys? Cotangent, thank you. So I'm just going to move the ordered pair over to our sheet so we can have that right next to it. So cotangent, how are we going to do that? Okay, do we need the denominators? So we would have 1 over negative square root of 3, which would become what? Negative square root of 3 over 3. Watch your signs carefully. Remember, this is not graded 5, 4, 3, 2, 1. This is all, there's a grading rubric for every question. So it says I have to take off 1 or a half or whatever for every little thing that's wrong. So number 5, what is this telling us? Well, it's asked in such a way that you should know what it's telling us, right? That's telling you what quadrant. So what is the first? Cosine is what? Greater than 0 means positive. The sign here is negative. Anybody know what quadrant that would be in? All students take calculus. Yes, down here, right? Because this means the cosine is positive and other things are negative. So we are in quadrant 4. I don't know if this is an explanation question. It might be. If it is, I would just say cosine is positive and sine negative in quadrant 4. I don't think you have to get too much more specific than that. So this was 4. You can use Roman numerals or not. I'm not picky. If we label this, we have the sign. Where do those numbers go? Opposite over hypotenuse. Okay, so we're looking for x. 25 squared minus 49 is 576. 24. Did I do that right? That was kind of a guess in my head. I mean, I know these triples, but all right. So the tangent is opposite over adjacent, or y over x. So it's negative 7 over 24. We good? Just gonna be real careful we don't make mistakes, and these are not hard, right? Number 6, solve this trig equation for all exact solutions in radians. Okay. I told you they weren't basic ones like we did on Friday. Do you remember what we have to do to this one? Very good. If you take out a cosine, what will it say? Nope.
Oh, no,
If you divide out a cosine from here, you'll still have a 2 and a cosine. And you divide out a cosine from here, you'll have -1. So that if you were to FOIL this back in or distribute this back in, I mean, you'd have 2 cosine squared minus cosine. Don't factor it wrong, because then you're done. All right, now it's take your turn being equal to 0. Either this is equal to 0 or this is equal to 0, which would make the cosine 1/2. We good? All right, and it says all, so I need to write plus or minus 2 pi n on the back, right? It does say in radians, not degrees. All right, so we go to the unit circle. Where is the cosine 0? Be very careful. Pi over 2, and then straight across at 3 pi over 2, which means there's a shorter way to write that, but most of you would probably just write pi over 2 and 3 pi over 2, so I'm okay with that. And then the cosine is 1/2. Cosine is positive 1/2 at pi over 3 and 5 pi over 3. Very careful that you're looking at the right one. And then all those need a plus or minus 2 pi n unless you're going to write them in a shorter way. The last two, there really isn't a shorter way to write it. The first two, because they're straight across from each other, you could have combined those and just written pi over 2 plus or minus pi n, and then you wouldn't have needed this one. But these last two, there's no shortcut. You don't need the shorter, it's fine. I'm not going to be picky. Questions? Okay, if you're thinking you need another example of that later, put a little mark by it and I can make up a whole bunch. All right. Number 7, identify the number that changes the period. Okay, how does this go? If I put an extra page in here, we have, I'll use letters, A sine B x minus C D. How did this all work, guys? Okay, this is amplitude, which is a vertical stretch, right? It could also, if it had a sign change, it could also be a reflection. What does B do? Yes, this affects period, but it's 2 pi for sine or cosine, which is what's on there. It's 2 pi divided by B will give you the new period. And this is a phase shift left or right. And this is a vertical shift up or down. Everybody good? More time. So which number in this question is affecting the period? Well, in this question, it would be the 3. But in this question, there's no parentheses, but it's still whatever multiplied onto the x. Yes. And the new period is 2 pi divided by 3 pi over 5, which would be 2 pi times 5 over 3 pi. And this is on the numerator, so it's 10/3. Very glad I don't have to graph that. Any questions? Okay, identify the phase shift. So phase shift means left or right. It's in the parentheses as long as we're in factored form, and it's given in factored form on the quiz. So this is a shift of pi over 6 to the, be very careful, do you remember? Yes. Everybody good? None of us should get those wrong, right? Okay, now we have to actually graph one and label all the quarter points. It says accurately sketch at least one period with this of this function. Okay, what two things have changed here? The amplitude is 4, is 2 pi divided by this b value of 2. So we get the period is pi. 1, 2, 3, 4. All the maximums are going to be up here. All the minimums are going to be down here. -4. Okay, do you remember the difference between cosine and sine? Which one goes through the origin? Okay, sine starts at the origin. And cosine starts where? Okay, it starts at the maximum as long as it's positive, right? So this is a cosine graph, so it's going to start at the maximum. And where is it going to be back at the maximum? This one had a period of pi. So halfway there, it's at a minimum. And halfway between, it's crossing the midline. So there's one period. You could draw more than one period, but you need to label 5 ordered pairs within one period. So anybody want to start? Yeah, I literally have to say, because I will get them all backwards if I don't. Across 0 and up 4. Okay. This was pi where it finished. So to do quarter points, remember you always take the period divided by 4 will give you the quarter points. So in this case, the period of pi divided by 4 makes this 1 pi over 4, 2 pi over 4, which reduces to pi over 2, 3 pi over 4 pi. Everybody good? Remember quarter points? If you need me to do some funky, icky ones in a few minutes, remind me and I can do some more. So the next point was to the right pi over 4 and up 0. Then to the right pi over 2 and down to -4. To the right 3 pi over 4 and up or down 0. And then to the right pi and up to 4. So there's one that isn't too funky. I think this might be the one question that I put an extra practice on. There's not actually 2 of these on the quiz, but I put 2 on the review. Does that seem right? Oh, maybe it's the writing equation I put 2 on. All right, so I only put 1 that you had to graph. We can definitely practice some more when we're done if you need to, but this is a writing question. It says you must call it a sine graph. Okay. So it doesn't say whether you have to do left shift or right shift, but you can't call it cosine, it says. So any preference whether we shift left or right? I would suggest you need to draw the midline. If this is -4 and +2, where's the midline, guys? Yes. 1, 2, 3 units down this way, 1, 2, 3 units up this way. So the midline is here. So the sine shape starts at the midline. Oh, sorry, I don't know what's going on here. The sine shape starts at the midline like this. So I would suggest we could start right there. Halfway to pi over 2 would be what? So we're going to start here at pi over 4. And we need 1 period, so it's going to finish. Anyone know what that would be? If this was 1/4, 2/4, 3/4 pi, the next one would be 5/4. Okay, so how do we decide what the period is? The period, by definition, is the length of the cycle. So if it starts at pi over 4 and it finishes at 5 pi over 4, how long is it? Okay, so the period is pi. What else can you tell me? Okay, since we went from a midline of 1, what does that midline tell us? Yes. The midline tells us the vertical shift is down 1. The amplitude is how far above and below that it's going, which was 3. Okay. And the b value, just like 2 pi divided by b gave you the new period, the same is true the other direction. 2 pi divided by the period will give you b. All right. So 2 pi divided by pi makes b just 2. Questions on that? And is there a phase shift?
Yeah.
Yeah, we started here, which was at, so we said we're going to shift it to the right, pi over 4. We could have gone all the way over to the left over here. We could have gone to the left and done a negative sign. But if we start here, okay, can anybody write the equation? Did we need a flip where we started? No. So out front goes the amplitude of that it had to be a sine. Then goes B. Any phase shift. Right would be. And then at the back would be any vertical shift after we close. Probably should have 2 parentheses here. Yes, you're right. It's down 1, so it should be -1. Okay? Yes. I would accept without both parentheses. Just make sure you have the inner one because the 2 has to be outside. But the calculator would bring up this one, so you really should practice closing. Because you can definitely type this in your calculator, guys. These are the kind that I would put a little mark by, finish my 14 questions, and then come back to and type in my calculator and check it. What mode would you be in? And what window would you use? Whatever they have right over here, right? If you want it to look just like this. Okay. So negative 2 pi to 2 pi and negative 4 to 3 or something. Then it should look just like that in the window. All right, what's happening here? We have to do sine again. Let's write a sine equation. Yep. So if this is 3, halfway to 3 would be 1.5. Half of that would be 0.75. But I don't know, is that where you want to start? You'd have to call it a negative sign, or you want to start over here. Any preference? Or we could start over here, shift left. Okay, so you want to start here. So the phase shift would be to the right, 0.75. All right, let's maybe label these then. 0.75, 1.5, 2.25. 3, we're adding 0.75, and 3.75. So how long is a period? On this one, yeah. Yeah, and an easier way maybe to do that. What's up, Mr. Brazil? Oh, thanks. Apparently there was a mistake on the key. If you've been checking this weekend. I might have noticed right away that the period was 3, just because there's one cycle, even though it's cosine, right? And it finished at 3. So that's the period. Whether it's sine or cosine, every cycle is the same. So the period is 3, whether we're talking sine or cosine. So here, from 0.75 to 3.75, that is a period of 3. So then 2 pi divided by 3 would become our b value. Does that work? If you took 2 pi divided by 2 pi over 3, would you get a period of 3? You'd end up with 3, right? Okay. Amplitude or vertical shift, either one, anybody? Here's the midline. Can you tell what that's supposed to be? Negative 20, 0, positive 20, 40, 60. Is that looking good? So the vertical shift is what? Vertical shift is where the midline is, so it's up 20. And the amplitude would be 20 down to negative 20, which would be 40, or 20 up to 60, which would be 40. So the amplitude is here to here, or here to here, which is also 40. Okay, anybody got the equation? But you told me to start here and go down, so it would be a reflected. Yep, or 3/4. It's kind of weird that we're using decimals and fractions, but I would take it. I don't think it's quite this complicated on that. The vertical shift goes at the end. Everybody okay? Kind of miserable. We can find some more practice if we need to. All right, this is probably the one that makes me the most nervous because it has so many parts, it's worth so many points. Develop a cosine equation, okay, to model the situation described and find Charlie's height at 11 seconds. Justify the amplitude and period of your equation. So this has a part that you have to explain how you got it and why. Charlie's on a Ferris wheel and his friend is timing the ride. He starts the watch when he is at the highest point, 22 feet in the air. Okay, we are in so much luck if he starts the watch at the top, what can we call this? Without a phase shift, right? It's starting at the max. The wheel has a diameter of 14 feet. Okay, this just kills you guys. If he starts up here and he's 22 feet in the air and it's 14 across, draw yourself a little picture, but what does that mean about the lowest he ever goes? No? 22 minus all the way across is 14, so that means the lowest he ever gets is 8. Okay? I don't know if you remember this, but the radius is always the amplitude. Okay? So if he starts at 22, all right, at the highest point, 22 feet in the air, has a diameter of 14, so the lowest he ever gets is 8, and he makes one revolution every 40 seconds. So this is time, so where is this that he's back at the top again? This one is so much easier without a phase shift, right? Okay, but you still have to find the midline. How do you find the midline? Yes, it's the average. What's halfway between 8 and 22? Okay, so how far above and below is that? 8 to 15 is 7. 15 to 22 is 7. So where's the 15 go and where's the 7 go? Some of you find those numbers and you get them backwards every time. Yes, 7 is the amplitude. And you could say the radius of the Ferris wheel equals 7, which is the amplitude. Or you could say 7 is how far above and below the midline he goes. That would be fine. All right, what is the period? Okay, and how can you justify that? Okay, but you want to say the period is, yes, length of one cycle or revolution, and it says that's 40 seconds. You can use complete sentences or not. I'm not going to be picky on that. But if it says explain and it has a blank, it means you get points for your explanation. Does that make sense, guys? So don't leave stuff blank or you lose points. All right. They didn't ask for a whole bunch of our stuff here. Well, it did ask for amplitude and period. The only thing they didn't really ask for is what? Well, they didn't ask for B or the vertical shift before we start filling them in. We said there's no phase shift. The vertical shift is up 15, and B would be 2 pi divided by 40 or pi over 20. And if you left it 2 pi over 40, it's not wrong. I don't care. All right, so what goes first? They already started the equation for us. H of t, or the height in terms of time, is equal to amplitude. Okay, we're calling it a cosine. B goes next. And because you're going to have to type this into your calculator in a minute, you have to have those parentheses when you type it in, so I would write them down. There is no phase shift, so you really could leave off the inside parentheses, but you got to have the one here. It's going to come up on your calculator anyway. and then the vertical shift to 15. All right. What mode should my calculator be in? Not sequence either. Radians and what? Function. That's all you'll need on the post-test, guys, is function. Okay. It has sequence questions, but I didn't use sequence mode, I don't think. All right. So we're going to go to y equals, and you just told me, I already forgot, 7 cosine. Now brought up the parentheses, pi over 20. Yeah, and you really don't need an extra parenthesis, but I'll put one. Plus 15. Okay, let's think about a window. This is time. So you could put a little negative if you want, but they want to know what's happening at 11 seconds. So I think we should just go out to at least 40 so that we can see one cycle, right? Make sure it's making sense for our equation. Y is up and down. How high did we say it went up? 25 maybe. Okay. So I'm going to trace at 0. He's at 22. At, what was the cycle? 40? He's back at 22. So if you wanted to check at 20 that he's making a height of 8, the minimum, that seems fine. But we really need to know where he is at 11. So we get 13.9. If you didn't want a graph, is there another way to do that? Yeah, we could just go to the home screen if you didn't want to check that your equation was right. And just type, somebody tell me, 7 cosine pi over 20 times 11 plus 15. Is that right? And you should still get 13.9. Okay, everybody good? That brings us to, I have an extra modeling if you want me to come back to that one. I think this is the last thing on there. All right, is the inverse trig functions. Do you remember where this is on the reference sheet? Underneath your unit circle. We talked at length about this on Friday. Sine is these two quadrants. Cosine is these two. Tangent is these two. But the big deal is if you wind up down here anywhere, you have to call those negative pi over 6, negative pi over 4, and negative pi over 3. Right? Okay, so going to question, okay, where's the sign negative square root of 2 over 2? You go to the unit circle. Where did my unit circle go? There we go. And negative square root of 2 over 2 for sine is down here. And you can't call it 7 pi over 4. You have to call it negative pi over 4. It's not going to be numbered that on your unit circle. The cosine of negative 1/2 is not in that quadrant. Where are you going to look for a negative cosine? Oh my goodness. Can't find them. Negative 1/2 is here. Is that okay? It's never in this quadrant, guys. Inverse trig functions don't use that quadrant at all. The only place cosine is negative is there. So we have 2 pi over 3. Or tangent. So the question was, do we only have negative fourth quadrant stuff, but it can be negative if it's tangent or sine. Okay? Anything that's in the fourth quadrant. Okay, create and complete a sketch The appropriate quadrant. Okay. So where is the inverse tangent or arctangent negative? You have this reference sheet. Okay. Tangent is in these two quadrants. So which one is going to be negative in? All students take calculus. The only place it's negative out of those two is the fourth quadrant. So you have to very carefully draw this in the fourth quadrant. Okay. Now tangent is labeled how? Sine over cosine. But yeah, y over x was right the first time. So this is negative 15 and this is 8, or do I have my sign on the wrong one? You went right and down, correct? Okay, I'm supposed to list, now that I've drawn it, I don't need the rest of that. I'm supposed to find the sign at that same spot. So I have to do Pythagorean theorem. 289 maybe? Which is 17. And then the sign would be what? Opposite over hypotenuse, or y over r, negative 15 over 17. Everybody okay? All right, what do you need to see more of? Okay. So if you had to graph y equals 2 sine 3 theta. It has no vertical shift, so it's going from 2 to negative 2. The period is 2 pi over 3 because of this b value. But then you always divide by 4 to find the quarter points. Or times 1/4, right? Same thing. So that would become 2 pi over 12, or pi over 6 would be your quarter points. So you'd have pi over 6. What's 2 pi over 6 going to be? 3/6. Yep. And 4/6. 2/3. Okay. If it was sine, it would start here, 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 and sorry, that was really bad. And it would finish at 2 pi over 3. So to find quarter points, you take the period divided by 4. Will give you what you need to count by to be quarter points, okay? Questions? All right, so this is what's in tomorrow's. If you need more practice or you want to just do this all over again tonight, there are extra copies up here.